Hello friends, welcome to Dennis Simplifies. In this video, we are going to be printing all prime numbers less than or equal to 1000 in C++. As usual, the algorithm first and then the code. So, let's simplify. A prime number is any positive integer that is divisible by itself and the number 1. Write down a computer solution that can display as output all prime numbers less than or equal to 1000. So you are printing all prime numbers that are less than or equal to 1000. So you're going to set a for loop that's going to run from 2 to 1000. And we're going to increase it by 1 until it gets to 1000. Now, why are we not starting from 1? We are not starting from 1 because obviously we all know that 1 is not a prime number. Now we are going to create an empty variable called number of factors. Now this empty variable number of factors is going to count the number of factors of any of the numbers from 2 to 1000. Alright, now the position of this number of factors is very important. Now you're going to set another for loop that is going to run from 1 to I, and it's going to keep increasing by 1. Now the reason why it is starting from j equals 1 to I is that the I in this case when we start was going to be 2. We know that the factors of a particular number can never be greater than the number itself. For instance, if I take 3, the factors of 3 are 1 and 3. 4 can never be a factor of 3. 5 can never be a factor of 3. So all the factors of a particular number are less than or equal to that particular number. So if I take 2 for instance, like 2 in this example, so for j equals 1 to I, so you're going to run j from 1 to 2. So you see if I modulus j equals 0, the number of factors plus n4. Meaning, if I take the I value, which is 2, modulus j, which is 1, and I get no remainder, or I get a remainder of 0, then it means that it is a factor of it. So you should increase the number of factors of that I by 1. Then we increase j again to 1. So this inner for loop is going to run till I, and be counting each time. If that number goes into I without any remainder, then it will increase the number of factors by 1. Then outside this for loop, N4, outside this for loop, I'm going to say that if the number of factors of that particular I value, which is 2, if it is the number of factors is equal to 2, then that I is a prime number. N if, and then N4. Now, I'll go back to the top of the loop and then increase I by 1. So now I is going to be 3. Now remember that number of factors is the number of factors of 2. So before I count the number of factors of the next number, which is 3, I have to empty the number of factors. That is why I told you the position of the number of factors is very important. So we have the number of factors in here, and we say the number of the factors is now equal to 0 again. So empty it before we enter this for loop to count the number of factors of 3. So now j is going to run from j equals 1 to 3, and then step 1. And then it is going to take the 3 modulus j, which is 1, and check if it is a if it goes into the 3 without any remainder, then it's a factor. Then j will increase it to 2, then it will check, then increase to 3, then it will check. Now when it gets to 3, it will end. Then it will come down here and check if the number of factors is equal to 2, then that 3 is a prime number. Alright, so this is going to keep on looping until it gets to 1000, and it's going to print all the prime numbers from 2 to 1000. Now let's convert this to code and see how it is. So in the int main function, I declared I, j, and a number of factors to be integers. Then I set the for loops, the outer for loop and the inner for loop, with the outer for loop being the number running from 2 to 1000, and then the inner for loop from 1 to I. As I said, it's from 1 to I because the factors of a particular number cannot be greater than the number itself. Like when I have 6, the factors of 6 cannot be greater than 6. They are all less than the 6. So I'll be checking if the factors go into that number. If the numbers go into the I without any remainder, then they are factors. So I'll increase factor by 1. Then if the number of factors is equal to 2, then that particular I number is a prime number. Then I end my code with system pause and then return 0 by custom. Now let's see how our code is going to print the prime numbers from 0 or from 2 to 1000. So you can see here that 2 is a prime number, 3 is a prime number. So it's printing all the prime numbers from 2 to 1000. So we can see also here that it ends. So the last prime number within 1000 is 997. So you have 997 as the last prime number under 1000. Alright friends, that's it for this video. Hope you learned something. Don't forget to like and subscribe. See you in the next video. Till then, I'll party.